Welcome to another Geography 215 math video. This video is about Chapter 8. The learning objectives for this chapter are to learn about wind conversions, pressure at different altitudes, Coriolis effects, and vertical motion. If you look in the appendix of your weather studies book, you will see this table regarding wind conversions. This will be helpful for question 1 on your math notes and math questions. Let's look at this wind conversion. 45 miles per hour equals how many knots? Looking at the table, there are two ways we can convert this. Let's go with the bottom red box. You can also use the top red box too. First, set up your conversion. Take 45 miles per hour and multiply it by the conversion, which is 1 knot for 1.15 miles per hour. You want to get your answer in knots, so you'll put that on top, and miles per hour will go on bottom because you want them to cancel. After miles per hour cancel, you multiply across and get 45 knots over 1.15. You can use two decimal places. The answer will be 39.13 knots after you divide. Therefore, your answer for this conversion will be 39.13 knots. Let's move on to pressure gradients. Let's take this problem. Based on the standard atmosphere, regards to table 5.2 in your weather textbook, compute the vertical pressure gradient in millibars per kilometers between sea level and an altitude of 6 kilometers. Your answer should be in millibars per kilometers. So again, for this problem, you'll want to use table 5.2 in your weather studies textbook. On the table for this problem, you're going to want to find the pressures at the two altitudes you are given. In this case, 6 kilometers and 0 kilometers for sea level. Next, you'll want to set up your equation. Since you do not want a negative value, you want to subtract the 6 kilometer millibar value from the 0 kilometer millibar value over the difference in height, which is 6 kilometers and 0 kilometers in this case. Since sea level has 1013.25 millibars and 6 kilometers has 472.17 millibars, you will want to subtract them on top and divide it by 6 kilometers, which is the difference between the altitudes. You will get 541.08 millibars, and again, you want to divide it by 6 kilometers, giving you an answer of 90.18 millibars per kilometers. Therefore, your answer for this problem will be 90.18 millibars per kilometer. For question number 3, it is more conceptual. This question reflects careful reading about the horizontal air pressure gradient and the Coriolis effect both in the beginning sections of Chapter 8 in your Weather Studies textbook. The paragraph begins with the magnitude. For question number 4, this figure 8.6 in your Weather Studies textbook, shows the Coriolis effect impacts. Notice that the poles it is the strongest. For question 5, let's take this question. In a typical extratropical cyclone, the vertical motion of air is typically only 1% to 10% of the horizontal wind speed. If the horizontal wind is blowing at 40 kilometers per hour, what is a reasonable value for the vertical air motion in a cyclone? So for this problem, Convert the percentages to decimal values, and then multiply each decimal value by the speed of the horizontal wind. So the percentages to decimals are 1% equals 0.01 and 10% equals 0.10. Next, multiply both by 40 kilometers per hour. This gives you 0.4 kilometers per hour and 4 kilometers per hour. Therefore, your answer to this problem would be between 0.4 kilometers per hour and 4 kilometers per hour. This ends the Chapter 8 math video. Please let me know if you have any questions. Have a great week.